So the next type of instruction is program status register instruction. Now, the ARM instruction set provides two instructions to directly control a program status register. So all of us know we have two registers, CPSR and the SPSR. This we have already discussed. Now we have two instructions to transfer those contents into the register. How it is? The MRS instruction transfers the contents of either the CPSR or SPSR into a register, normal register. It could be from R0 to R10 or R12 we can make use. So any of these registers we can take it and we can load it into the general purpose register. So in the reverse direction, we have an instruction MSR, means it transfers the contents of register. So whatever is the contents there in the register, that we can transfer it to CPSR or SPSR. So together these instructions are used to read and write the CPSR and SPSR. So now let us see the syntax here. So all of you know the 32-bit status registers. 0 to 4 will denote the modes. Fifth one, sixth one and seventh one will talk about the different, all these are different types of modes we have already seen. Interrupt, fast interrupt, we have seen, and these are thumb mode. This is a thumb mode, and these are different privilege mode, user mode, supervisor mode, all these things. And here 0 to 7 will talk about these modes and the flags, and 8 to 15 is an extension for further usage. This we are right now not using, and 16 to 23 is again the status, again we are not right now using. Among the fields 24 to 31 we have few flags starting from 28 to 31. So these bits, they are fixed, it won't change. So these bits will denote each flag, negative, zero, carry flag and overflow flag. Now this is what we have seen earlier also. Now we want to do some manipulations in any of those bits, we cannot directly do. So what we do, we'll take this entire 32-bit, we'll put it into a register, and in that register we'll perform some operation, we will change there, and that the contents of that register will put it back to the status register. So automatically it gets affected. So for that we are having these registers called as MRS. So condition is again optional. This is the destination and source is CPS, either CPSR or SPSR. So MRS will move the contents of either of these two registers to the normal register. MSR from the register, it will move to any of the CPSR or SPSR. We can specify the fields also. So what do you mean by fields? C will talk about the control fields. 0 to 7, we call it as control field. 8 to 15, we call it as X, means extension field. 16 to 23, this field is noted by S. And 24 to 31, these fields are denoted by flag. So any of these bits we want to change, this we can specify. Similarly, the same thing MSR. Instead of the register content, what we can do, we can pass some immediate value. Okay, that value we can pass it to this particular CPSR or SPSR to the specific field. We'll see some examples. So that's what MRS, it copies program status register to general purpose register. MSR, general purpose register to a program status register. This one MSR with an immediate value also we can push it. Now let's take up an example to enable IRQ interrupts. Means we want to enable it. So we want to unmask. Presently the processor is idle, it can handle the interrupts. So we have to enable the IRQ. So for masking, we will always make it as 1. For unmasking, okay, we will make it as 0. So this operation involves, we'll make use of both registers instructions, MRS and MSR. So let us explain with an example. Let us see the status of CPSR. What is CPSR? You're seeing all these flags are 0, negative, 0, carry, overflow, saturation flags are all are 0. And right now we are in the supervisor mode. And you're seeing I is enabled, means it is masked. Presently the interrupt flag is masked, means the other device cannot raise an interrupt. It is masked. So it is disabled for other devices. You have to take it in that sense. It is disabled for other interrupts. Now we want to enable for the other devices interrupts. So for enabling, we have to make this particular bit as 0. So now let's see the example here that ith bit, I is nothing but this, actually 0 to 7, it's the 8th bit. Since it is starting from 0, it is the 8th bit. So this 8th bit, we want to make it 0. Right now it is 1. So how will we do it? What we do, first we take the CPSR contents to R1 using MRS instruction. So R1 will hold the entire 32-bit contents of CPSR. So the entire 32-bit content is moved on to R1. But we don't want to disturb other bits. We want to take only the last control bits, and that to the 8th bit. So what we do, we'll take R1 and we will actually same thing. Bit clear, we will do bit clear instruction. So we will do bit clear with 80. So all of you know 80, it's bit clear. So 80 means like this, it will be 100000 like this. So this is the 8th bit. So bit clear, when once we make use of an instruction bit clear, there's 80. Okay, please don't take this. This is a small mistake. The 0 should come here. So that's why I've written here. So this is 80. What we have to do here, the 8th bit, we'll make it as 0. So this particular bit clear will first perform ones complement. So you have 80. That 80, when you do ones complement, you get this value 0111. To this value, we will add the R1 contents. Means whatever is there from 0 to 6, these values are ANDed with ones. Means whatever is a value, the same value is retained. Only this particular 7th bit is ANDed with 0 because of bit clear. So immediately that particular bit becomes 0. Only the 8th bit will become 0. Rest all whatever was there previously, it will be retained. So that will be the status. Remaining all are untouched. So it will remain same. That contents, we are moving it back to CPSR underscore C. That is what underscore C means. It is a control field. We are touching only the control field. Those last 8 bits, we are going to put it back. So in that case, only this bit is 0. Rest all whatever was there, the same field will be retained. So now what is the status of CPSR? You can see here, this everything is the same except here it was the interrupts were disabled. Now you're enabling it. Means you're unmasking. So when you make it 0, you're unmasking it. So you're allowing other devices to raise an interrupt. So in this way, you can try to enable the interrupts. So now let's go to the next type of instruction called as coprocessor instruction. What is this coprocessor instruction? Coprocessor is basically another type of processor. Many times the processor cannot handle all the instructions, all the operations or functions. So that will be implemented by coprocessor. It is something like a supportive processor. The processor, the main processor, when it cannot handle some instruction, it will direct it to the coprocessor. And it will make the task to get it done. And later, the main processor will continue. And we can also make the coprocessor to execute few tasks. So what is that? Coprocessor instructions are used to extend the instruction set. So whatever is not possible by the main processor, coprocessor can do it. A coprocessor can either provide additional computation capability or used to control the memory subsystem, including caches and memory management. So it just works like the main processor, but what functionality the main processor doesn't support, that will be supported by the coprocessor. The coprocessor instructions include data processing, register transfer, and memory transfer instruction. So this is what you're seeing, coprocessor. CDP, this is nothing but coprocessor data processing instruction. Maybe some kind of operations we are performing, addition, subtraction, multiplication, like that. And we have another instructions like MRC, MCR. These instructions, what we do, we are trying to move the data from one register, coprocessor register to another coprocessor register. So data transfer instruction among the coprocessor registers. And the other one is LDC and STC. Means from the coprocessor, we want to load it to the memory, and from the memory, you want to load it to the coprocessor. For that, we are making use of LDC and STC. LDC is nothing but memory to the coprocessor. STC is nothing but the coprocessor to the memory. Now these are the different types of instructions, and you are seeing the syntax. So CDP, condition is optional. CP, opcode 1. CD is the destination register, CN is the source register, and this is the opcode. So opcode is nothing but it's a number given to every operation. For example, addition, subtraction. Here we don't specify addition, subtraction. We give an opcode like assume addition is number 2 and subtraction is number 3. So when I write 2 here, it will understand it's an addition. I'm telling it in simple terms. So that is how we are specifying here. So let's take an example, CDP. And what is this? There may be more than one coprocessor. I'm telling P5 means this is the fifth coprocessor. Opcode 1, assume this is an add instruction. So I'm specifying 2. And CD is C12. CN means there are two source registers, C10 and C3. These are the registers, C10, C12, C3, all these are coprocessor register. What I'm trying to do, assume I'm performing addition. So it will, this instruction will direct the coprocessor number 5. It will take the contents of that coprocessor register C10 and C3. It will add those two and store the result in C12. And the next opcode will tell what is the next operation it has to do. Again, it is optional. If you want, you can specify. Otherwise, you can just remove that. This is one simple example that I had taken for coprocessor instruction, like processing, data processing. Similarly, we can use for the data transfer. Same way, this CP tells the which coprocessor, opcode will tell what operation, RD is the destination, and these are the sources. So LDC, STC, same thing we are doing. What type of addressing we are doing, direct addressing or some indirect addressing. This will be specified based on that. So this is one simple example we have taken. So now let's go to the loading constants. So unlike the other processors in ARM, we don't have an instruction. We don't have an instruction